Hi, I'm John Kappenman. I'm a researcher, investigator in regards to space weather, especially their impacts on electric power grids. And I'm speaking to you today from Duluth, Minnesota.
Great. And we have a solar storm going on right now. Is that right?
Yes, that's right. We had an M9 flare very early yesterday. It produced a radiation storm within a matter of an hour or so after the flare yesterday. That radiation storm largely poses risk to satellites, perhaps astronauts, aircraft at high altitudes and at high latitudes.
Put that in context for us. How often do we get flares like this, and what happens when we do?
Well, the best way of measuring the intensity of the flare is to look at its X-ray energy emissions. This flare was an M9, meaning a major 9 intensity storm. We get X-class flares all the time. X-class flares, for example, an X9 intensity flare would be 10 times larger than the M9 flare. In the previous solar cycle, 2003, we saw a flare that actually saturated the measuring instruments. We made an estimate of that flare that the energy would have been about an X30, X35 sort of class. So that flare would have been 30 to 35 times larger than the M9 that we had just a few days ago. So that kind of puts it in context.
You see the initial radiation effects when the event happens, but the actual coronal mass of these ions hitting us happens 2 days later. That's right.
We'll see the X-rays, of course, and other radio frequency emissions travel at the speed of light, so there's only an 8-minute delay. The coronal mass ejection, that travels at a slower speed, in this case somewhere on the order of about 4 million miles per hour. Today, the coronal mass ejection from that solar flare has arrived at Earth, and it's in the process of producing a geomagnetic storm. Now, the coronal mass ejection arrived about mid-morning our time in the U.S. We have only seen the beginning of the passage of this coronal mass ejection. So far, the storm that's being created by it is relatively small, but it is traveling with very high speeds. It'll be difficult to exactly predict how significant this storm will be, but we expect it only to be about moderate intensity.
The main effect was rerouting planes with polar routes. Was there any other impact that you're aware of to any systems?
Not yet. The geomagnetic storm is just getting started, so and we don't know until we actually see what the solar wind parameters look like. The main part of the CME has not arrived yet. We're only seeing the advanced shock wave of that CME.
So when will we expect the peak for that to arrive?
Well, I would expect it within the next few hours that we'll begin seeing the actual CME. Generally, a CME will, its encounter with the Earth's magnetic field will generally last on the order of about a day on average. It is huge in comparison to the Earth and the Earth's magnetosphere, so it can persist for a fairly long period of time. One needs to look at the magnetosphere as almost being like it has an ability to store energy. It becomes disturbed. It sucks in the particles or plasma from the coronal mass ejection. It builds up momentum, and then with each successive CME that hits it, it's much like adding energy to a flywheel, in effect. And in that process, it can produce ever more violent reactions and storm disturbances of the Earth's geomagnetic field.